Okay, I'm going to start in 5, 4, 3, 2, 1.
All attendees are in listen-only mode.
Good morning. Welcome to the DBAFundamentals virtual chapter meeting for May. Today's presentation is entitled Beyond CXPACKET, Understanding Weight Statistics. It's going to be presented by Jes Borland. I'll be turning things over to Jes in a minute, but I've got a few things to go over first. Let me get this thing running. My PC's not running very good today. Maybe I'll go to the next screen. Maybe I won't. There we go. The PASS Summit 2016 is coming up in October. There's the dates. October 26th through 28th. Recon starting on the 25th. And there's deadlines in case you want to attend on the pricing. And there's quite a bit of difference. We just passed a deadline about 2 or 3 weeks ago that had it go up $300. Then there's one that is happening July the 17th where it goes up another $400. In addition to that, we, along with all the other virtual and local chapters in PASS, have discount codes for $150 off. Be sure you take advantage of that. We are going to put everyone that uses our code in a pool, and at the end of the period that we do this, I think it's probably around in August. They haven't officially told us when that'll be. We're going to put everybody's name in a drawing, and one person will win a $300 Amazon gift card in addition to the $150 off, and in addition to, if you can get it before July the 17th, an extra $400. So be sure and don't miss that no matter whose code you use. As I said, there's plenty of other virtual and local chapters. The virtual chapters, that's what we are actually are across practically every topic you can think of. There's a lot of different ones coming in with different languages and different industries. So I know there's one on healthcare, and there's a lot of healthcare in our area. So just go out there and go to SQLpass.org/VC and check them out, join them up, and they've got tons of content that they've archived and tons of brand new fresh content that's coming along. Here's our sessions coming up during the summer. Next week, our Down Under chapter, which it's scheduled on Tuesdays at 11, second Tuesday of the month, but in actuality, given where they're at, Brisbane time, you will actually see it if it's Central Daylight Time here in the U.S. at 9:30 p.m. the night before. There's a real good one on SQL Server encryption coming up. We had that one scheduled earlier in the year, and technical difficulties. Basically, I forgot to do a few things and caused a problem, and we didn't get to show it. So try to make it to that. In June, we've got a real good one coming up from a lady that's had 20 years of experience with security that's going to go over all of the different things that you need to be aware of with SQL Server security. It's going to be things that maybe you don't have control over, but you need to be aware of them anyway. So that's a real good session coming up. And in June, we've got a third session. It's going to be a little tight June and July for us, to where we're actually letting the Microsoft Tiger team, a lot of other virtual chapters are doing this also, do some extra presentations, and they're going to be focusing on newer enhancements with 2014 and 2016. And the enhancements that will make your SQL Server roar is June the 21st, and the one coming up in July the 19th is SQL Server Performance Monitoring and Baselining. Anyway, you get an email every once in a while from me, so you should be able to sign up for those if you want to. We will record the sessions, and if you want to go up and if you want to just hit the little camera on the top hand side of your presentation, you can record this, and you've got our YouTube channel, and you can subscribe to it, or you can go to our fundamentals.sqlpass.org meeting archive. We have any scripts or demos are loaded on our site, and then you can always go see the recordings on our YouTube channel. Okay. System is a little slow. Okay, the next one is just stay involved, so don't worry about that. Okay, let's get this thing turned over to Jes. Jes is a Senior SQL Server Engineer with Concurrency, and she's a Microsoft SQL Server MVP. She's been around. You've probably heard of her before with Brent Ozar, but she's working out in the business world now, and which that was a business too. But anyway, sorry. Anyway, I'm going to turn over the session to Jes beyond CXPACKET, Understanding Weight Statistics. Let me flip my screen over, make her presenter.
Evening, everyone. Glad to see everyone could take an hour out of their day to join me. I am going to be sharing understanding weight statistics. As was mentioned, I'm Jes Borland. I'm a Senior SQL Server Engineer at Concurrency based out of And one of the things that I found most confusing, and that probably took me the longest to learn, was weight statistics, because they're practically this foreign language, and what do they really mean? So hopefully my presentation today will help clear up some of the confusion around it for you. One quick plug I would like to give you is this session originally debuted on SQL Cruise Caribbean 2016. The benefit of that was it was a 2-hour session. I was able to ask all of the attendees beforehand. And after I gave the session, we actually went through them as a group and gave individual people recommendations for what they could change on their servers, what they could look at to make their servers run faster or run better. So check out SQLcruise.com if you're looking for a very in-depth training experience that gives you longer sessions to talk through. So let's start with the very basics of this topic, which is, what are weight statistics exactly? Well, understand that SQL Server is comprised and running of a bunch of resources. CPU usage, reading stuff off the disk. Every time that SQL Server runs any sort of query, it could potentially be waiting on any one of these resources. Even if it's for a millisecond, it still has to wait to be processed. Server uses each of these resources, it logs them as weight statistics in a DMV. We'll get to that, what that DMV is and how you can get it, but let's just kind of understand SQL Server, reading data and writing data. Resource types that you're going to notice more when you have a read-heavy workload, and some that you'll notice more often when you have a basic read request, just a select statement sent into SQL Server. The way that this works is we first send our request to needs is in memory, because SQL Server wants to read from memory. It's faster than disk. If it now, what if the data that you are looking for is not on that particular go ahead and read that data from across the network and put it in memory. Once it has all the data it needs, then it will get in the queue or the line for CPU usage. The client. So let's break that down a little bit just so you can understand what the individual weights that might accumulate are. Here I'm doing just a simple select statement, getting 3 fields, an ID, a title, and an answer. Date greater than and less than other dates. So we send the select into our server. It goes and it first checks for the data pages in memory. You know, the first time we've used the posts table in a while. In this case, SQL Server is going to go ahead and read the data pages off of disk. The weight statistic that you're going to see at that point is the page IO latch underscore, and there's a couple of options, but you'll typically see page IO server spending a lot of time reading the data off of disk and into memory. That's simple. We don't have to go across the CPU. When we're waiting, we're going to accumulate SOS Scheduler Yield weights. Now, once we're done being in the queue, we're actually executing. If the query is in serial or running on just one processor, it will just go ahead and run. If it is parallel, this is when you would see the infamous CXPACKET weight. After that, we would see, once it's finished processing, the data is sent across the network to the client, and that would be written as Async Network IO weight. Server. Page IO latch, again, meaning we're simply reading data off of disk and into memory. And Async Network IO means we're sending the results across. More so you understand how that works. Let's say we have a server with 8 logical or physical processors. Cores. And we have parallelism enabled. We have set our max stop to 4. I will not talk about what you should set your max. It has a cost higher than that cost threshold for parallelism. So SQL Server says, okay, we're going to split this out equally, 2 milliseconds across each particular thread that it's running on, but not always. Let's say that it runs here, 10, 9, 10, and 22 milliseconds. seconds of CXPACKET were used for this particular query. So that's why when you look at your server's been up for seconds of CXPACKET. It's possible. It's all of the cores combined together. All right, so let's go into just a slightly more complicated query. Here, we're doing a select, and I'm trying to see if I can get my little that'll make it easier. So here we're doing a select statement from posts, which is moat server, server b.database schema table. In this case, we're going to send the query into the system. SQL Server is going to check if the data pages exist in memory. In this case, they don't, so we're going to accumulate some page IO latch weights while those are read into memory. Now, SQL Server is going to go ahead and use a linked server to get the results that it needs from server B. This is one of the OleDB weights. Again, if you see a high amount of after it has all the data it needs, it sends it to the CPU, it executes it on the CPU, and it sends the results to the client. So again, this is another example of a common weight type that you would see and what could generate that. Okay, so now we're going to talk about yet another type of weight that you might see, and that's when TempDB is in use. Let's look at this version of our query from the posts table. I'm going to be doing a little bit of work here. I'm counting some things, so some aggregations. So in this case, I'm going to send the query into the SQL Server, and SQL Server is going to see if the data pages exist in memory. You notice this is a pretty common thing? Yeah, it happens every time. We read the data pages off of disk if we need to, and now in this case, we need to do some aggregations. Depending on the size of the data set that we are aggregating and how much memory we have on our system and how much of that is available for use by the query, we may need to use TempDB as our temporary, scratch pad. In this case, if TempDB needs to be used and we need to wait for latch weight. Notice that this is slightly different. When we're reading off of disk and into memory, it's page IO latch. When we're waiting to use a page that already exists in memory, it's page latch. So you can see page latch weights for databases other than TempDB, but TempDB is typically the most common. It may indicate TempDB contention. After our aggregations are done, again, after we have all the data we need in memory, we send it to the queue, we execute on the CPU, and we send the result to the client. So those are some fairly normal examples of just reading data, how SQL Server processes it through the system, and the typical weights you would see. But databases typically don't exist just to be read from, right? We go ahead and we write to them. So writing data does involve some extra steps and might show some other weights. Let's talk through those. In this case, the typical view for a write workload is that we send our query into the CPU. First things first, we check for the data pages in memory. Yep, even when we're doing writes, SQL Server wants to see the data in memory. If needed, we'll read the data pages off of disk or off the network. Now, the first thing that will happen is we need to wait for other transactions to finish modifying the data in order for SQL Server to follow the ACID properties of a relational database. Only one transaction can modify one piece of data at a time. So we get our hold on the object we need. We write the changes to the pages in memory, then the log file. The changes to the pages in memory and the log file are a synchronous option. I'm sorry, operation. Missed a few letters in there. After we're done writing the changes to memory and the log file, then behind the scenes, asynchronously, SQL Server is writing the changes to the data file. Now we get in the queue, we execute on the CPU, and we send the results to the client. So looking at a simple insert, update, and delete, we're going to see some of the same wait types, such as page IO latch, when we need to read the pages off of disk. Now at this point where we wait for other transactions to finish modifying the data brings us to the lock screen, the lock type, the LCK underscore. I'll have a screen on what those various types of locks mean, but this is where those would occur. Now, as we're writing the changes to the pages in memory and then the log file, we're getting write log waits. Pretty obvious, we're writing to the transaction log. Again, in the background, we're asynchronously writing the changes to the data file. Those changes come up as async IO completion waits. Now, again, we wait our turn for CPU, execute, and send the results to the client. Those wait types aren't going to change regardless of whether or not we're doing a read or a write. So that's a quick walk through the wait statistics that you would see on a basic read or write with SQL Server. Now, are there other wait types that could occur? Absolutely. Are there other instances where we might see things like resource semaphore waits? Sure, but those are outside the day-to-day normal waits. Again, I'm focusing on the 75 to 80% of the waits that I see most of the time as the most common waits on SQL Server instances. Now, you'll be able to download the slides to reference where in the process you'll be able to see those. Let's talk about the really important stuff, which is how do you know what your server is waiting on? SQL Server is logging these wait statistics to a DMV. Every time the server restarts, you're going to be collecting those in the sys.dmos wait stats query. I'm sorry, DMV. Now again, this is since server restart. That means that you should really take this with the results of that with a grain of salt. If your server just restarted an hour ago, you might see a lot of page IO latch waits because SQL Server's memory was completely cleared out and it needs to be redone. And everything needs to be requeried. If you are if it restarted at midnight, you're checking it at 8 a.m. and the only activity that's really happened since then is backups, you may see a lot of backup IO and backup buffer. On the other hand, if your server's been up for 6 months, 9 months, 12 months, and yes, I've seen that, it can be really hard to determine were those wait statistics, are those problem waits things that are recent, or is it something that was a problem 4 months ago and has since been cleared out? If you're experiencing a problem at the moment, you can use the sys.dmos waiting tasks DMV to determine what your server is waiting on right now. If you have a monitoring tool in place, There are many good ones out there. Most of them are collecting information about what you're waiting on a daily basis, so you can see, do you have a certain set of waits overnight versus during the day? Are there some that happen more, on the weekends versus the week when you're doing data loads versus just regular transactional information? What you really want to do and understand is that, like any other information in SQL Server, you need to have a baseline of it. What's normal for your servers? So either use a third-party tool that collects the information, or write a script to collect the information and store it in a table, and get an idea of what the typical waits are for your SQL Server instances before you rush off to fix any of them. The query that I would reference is to run for you to get this information is from the SQL Server Performance Tuning Using Wait Statistics white paper. It's a freely available download from the SQLskills.com website, and there is a primary resource waits query. I find that one that they wrote is excellent if you're just getting started with this. Now, once you have a list of what your servers have been waiting on, and once you've taken that list for once you've gotten that information for a few days and you have a baseline, what you're going to begin to establish is, are there problems? One thing you'll see is how long your server's been up versus how long these waits have been running. Again, if your server's been up for 8 days and there are 17 days worth of CXPACKET waits happening in that time period, yeah, you might want to mitigate it. If your server's been up for 96 hours and there's 1 hour of page IO latch waits, that might not be an actual problem. So what you really need to do first is identify, are the waits a problem? Remember, every time you run a select statement, every time you run an update statement, SQL Server is collecting wait statistics. What you really need to do again is have that baseline and determine, is this normal? Is it a problem? Now, if it is a problem, we're going to talk through what some of the most common fixes for these things are, because that's what you really want to know, right? You thought those diagrams were cool, and now you know where page IO latch waits are happening, but what causes it? And Jess, let's talk about how I can fix it. So let's say that you're seeing a high percentage of page IO latch waits. Again, this is caused when we have large amounts of data that are read off of disk and into memory. Now, what could be causing this? Well, we could have a small amount of max memory in relation to the amount of data that's read on a daily basis. How can you check how much data is being read on a daily basis? The sys.dm IO file stats DMV tracks that. I found cases where a server might have max memory set to 12 or 16 gig, but on average 96 to 100 gig of data is being read every day. That's a small ratio. That means that that data is frequently churning. You might correlate that with a low page life expectancy in perfmon. It could also be that we simply have queries that are not tuned well and they're doing a large amount of reads. We might find this where we see a query with a select star, or a query that has no where clause on it, or maybe 5 tables and only one of them has any sort of where clause on it. Things we can do to start tuning a query or a server where we see a lot of page IO latch waits. First thing I would do is query the plan cache or use an extended event session to find queries that have the most reads. Extended event sessions can capture queries that run with over 100,000 physical reads or more than 1,000 logical reads, which can help you identify that. When you look at queries that are running in the plan cache, you can look for the ones that do the most reads. From there, I would start tuning those queries. Can we, change from a select star to doing just a couple of columns? Can we add where clauses or add more refined where clauses to return fewer rows? Maybe we look at the execution plans of those queries and we see that we're doing a bunch of table scans or clustered index scans. To me, that would mean, hey, maybe some indexes would help. Now, what if we still see, maybe not, maybe it's the opposite, where we're not just seeing, 2 or 3 queries that do a major number of reads. Maybe we have one query that runs tens of thousands or hundreds of thousands of times a day and only does 5 reads each time. Guess what? That's still read intensive. Those are the kinds of queries where I ask the application developers, does this data change frequently? Do we really need to query the database server every 2 seconds to see if the data changed in the last 2 minutes? Or could we perhaps be using application caching? And another resolution, if none of those solve the problem and you have not hit your maximum value for SQL Server's max memory, if you're using a virtual SQL Server, go ahead and increase the max memory, increase the memory allocated to the virtual machine and increase SQL Server's max memory. If you're still using physical machines, see if it's possible to increase the amount of memory given to SQL Server and again, modify the max memory. So that's a quick spin through Page.io Latch and how we can mitigate those waits if they are a problem. Moving on, let's talk to the OleDB wait, which is that frequently linked servers or queries across the network. We might see linked server, we might see open query, we might see open row set. Another option or another common cause of this is some monitoring tools. It is pretty common or fairly common where I see that the most resource-intensive queries on a system are the system's monitoring tool. They basically are consistently running queries across the network to return information. Some DMVs and DBCC commands will also generate OleDB. So again, when you see this, you really have to dig into what could be causing it and is there something you can do to fix it. If you are having OleDB waits caused by large amounts of cross-server queries, again, things you might need to do. Use some way to combine the data onto the same server, whether that's moving databases or, what if you have to do replication? You might have to. Again, application level caching could help. And in some cases, maybe you do have a slow network. That's the case. A 1 gig backbone can only move so much data across in a minute or an hour. Compare that to, a 4 gig or 8 gig fiber channel or a 10 gig Ethernet. If the network truly is the bottleneck, you may have to update that. Now, what happens if one of our top waits is the page latch? Again, this means that the data pages have already been read into memory and queries are waiting to get their hands on them or use them. Most of the time we see this as TempDB problems, TempDB contention. Not always, but frequently. So what you really need to do here is if you see a lot of page latch waits, and you think that maybe TempDB might be the problem, or you wonder if it's a bunch of other queries trying to get the same data from one database, you can use that sys.dmos waiting tasks DMV, that one that tracks what's going on right now, to determine what resources are wanted. I'm going to refer you to Robert Davis's blog on breaking down TempDB contention, which has some excellent scripts and a walkthrough on how you can diagnose if that's the problem and how to fix it if it is. Following some basic best practices with TempDB will usually help. All right, so now let's talk about things that happen in the right world, those LCK weights. This is the current list of the common weights from books online. Yeah, that doesn't look confusing at all, right? Well, they can be broken up into a few basic types. You may see LCKS, LCKU, or LCKX. LCK_S means that we're trying to do read operations with no data changes. LCK_X means we're doing data modifications. These are basically grouped into a couple of different things. LCK, there are the different types of locks that tell us whether we're reading or writing. There are locks that tell us if we are trying to get multiple resources to get a lock on the same object, and thus what their hierarchy is. The SCH- locks can tell us when schema is being changed. The LCKBU tells us that we're waiting for something to do a bulk update. LCK_R, if you have serializable transaction isolation level, those are range level locks. So basically what you need to do is understand that when you see a high level of LCK weights, or if you see that there are LCK weights that have a long average wait time, and I've seen some that wait 30 seconds, 15 seconds, not even milliseconds, but 2 seconds, 10 seconds, 30 seconds that we're waiting on locks. Again, this means that multiple transactions want to typically update the same resource. If you can identify when these lock waits occur, you can again use the waiting tasks DMV to find the session IDs, and then use those session IDs to find the queries. Another excellent tool for finding currently active locks is Atom Mechanics SP Who is Active Stored Procedure. Now once you find those queries, you actually have to fix them, right? That's usually the hard part. We can talk about things like, are we trying to update all of the rows in one table at a time? Can we break that down into smaller chunks? Is it something where we're trying to do an update to a table and there's another query that's trying to read the table? It's not well written, or there are no non-clustered indexes on it, so we have two things that are trying to do clustered index scans at the same time. It really involves finding those queries and using basic performance tuning methodologies to figure out how to fix them. Now, what if we see the write log wait near the top of our wait statistics? Either large amounts of write log waits or perhaps long average times for the write log waits. Again, this is caused when we write to the log files. This is a synchronous operation. We have to finish writing to the log file before we send a note back to the application that says we're good to go. right? We need the transaction to be committed. So you can use that sys.dmio virtual file stats DMV to determine, okay, which log files are being written to the most frequently? Which ones have those longest write stalls? Then we start determining, how many writes are we doing to this log file? Is there any way to reduce the number of writes? Are we maybe doing some insert or update frequently or every day where we're truncating a table and reinserting all of the same rows? That's a much less common option than something like we just have slow storage. And yes, in this day and age, slow storage still exists. Maybe we have it where all of our data files, log files, TempDB files are on the same LUN, and it's just shared across a very small number of disks in our SAN. We may have to ask the SAN admin, very nicely of course, if we can go ahead and get a dedicated LUN for those log files. That could help. We could also just perhaps need to move the log files onto faster storage, particularly if you have tiered storage SAN and you don't have the log files able to sit on the fastest level. You might be able to put that in. So with write log waits, another option might be, you guys, I'm presenting. Another option may be that we need to look at that network again, right? Especially if this is not local storage. Are we sending these inserts, updates, deletes across the network? Are we looking at, again, a 1 gig connection between our server and our storage? Is there a way we can increase that or reduce the amount of concurrent traffic that's going across that? So there's a lot of things to look at with the write log wait. You really need to determine what the easiest and most effective way to fix it will be. All right, the other thing that we'll see when we're doing writes is, again, that we need to asynchronously write to our data files. So we may see that as async IO completion. Now, typically, if I see async IO completion as one of the top waits, I'm not overly concerned that it is there, because this typically doesn't affect how quickly insert, update, and delete operations finish. But if we write the data and then we need to read it immediately thereafter for another part of the application or another process, slow async IO completion could be a problem. Things that we can do here, again, review that virtual file stats DMV to see the slowest average write stalls for our data files, try to reduce the number of writes, separate the data files onto separate storage from the log files so we're not competing for both read and write operations, move the data files onto faster storage. Last but not least, this might be a reason for us to create multiple data files in our database, potentially even create multiple file groups and spread multiple files across each of them. I like to think that that's a last resort, though. Let's see if we can tune our queries first. Let's see if we have an opportunity to get better storage. All right, so now what if we see large amounts of SOS Scheduler Yield? Again, this is when we have a lot of things waiting in queue to get their turn at the CPU. The way that I typically see SOS Scheduler Yield waits appear in the weight statistics query is I'll either see a very large number of them with a very, very small average wait time, or vice versa. I'll see a very small number of waits that have a very long wait time. I have found that most of the time, if you have one query that is doing a very large scan, that can cause a few number of waits with a long wait time. On the other hand, I've also seen a query that executed, and I am not kidding you, 3,000 times per second. It only generated less than a millisecond every time, but 3,000 times in a second, every minute, for hours on end, adds up. What I had to do in that case was search the plan cache for the queries executed most frequently and go back to the application developers and say, hey, whoa, what are we doing here? And in that case, they were able to realize that that query did not need to be running that often. You could also, again, if you're seeing a few items that have a large amount of SOS Scheduler Yield, review their plans in the plan cache, see if there are any large table scans or index scans that you could change the query to tune. Last but not least, maybe you do need to increase the amount of CPU on your system. But again, I usually find that there are queries that can be tuned to solve that problem. And now the infamous, the most commonly referenced CXPACKET. Again, this is accumulated anytime that queries run in parallel. And it's that total cumulative cost of how long the query took to execute across all of the cores that it was given. I have seen the blogs and the forum responses that say, oh, I had CXPACKET. Oh, go ahead and disable parallelism. Not the answer. First thing I would do if I see high CXPACKET weights is I would go into the server settings and I say, okay, do we still have the default CPU settings? So, is cost threshold set to 5 and is max stop set to 0? If that's the case, I'm going to go ahead and configure those to say not every query that goes parallel needs to run across all of our processors. If that still doesn't solve the problem, if CXPACKET is still one of our top weights and we have certain queries that are taking longer than we want them to, so if performance is actually a problem, again, I go to the plan cache. I search for the most expensive queries by CPU, and I work to tune them. Typically, on a system that has parallelism enabled, I will see CXPACKET as the top weight type. And I generally don't panic about it. That's normal. All right, so now that last and final weight type, which can significantly accumulate over time, is the Async Network IO. So when the query is finished running, SQL Server needs to send it from the server across the network to the client. And from the time that the first byte is sent to the time that the last byte is received by the client, we're accumulating these Async Network IO weights. If I see that there are either a large number of these that take a small amount of time each, or a few of them that take a long time each, I'm going to start looking for queries that send a lot of data across the network every time they're run. Most frequent problem children I see with these are, and if you can see me, you can't see me over here, but trust me, I have my fingers up and I'm doing the double quote reports, right? Someone goes into SSRS, does a select star from these 3 tables, returns it into reporting services, exports it into Excel. 100 pages of Excel that no one's ever going to read. Let's find those things and say, okay, this isn't a report, this is a data dump, or this isn't a report because you're going into Excel and modifying the data further. Maybe we can work with you to determine what the report should actually say. Another thing that we might find is row by agonizing row processing, right? An application that's designed to just get a huge amount of data and then process it all in the application. SQL Server is actually pretty good at processing data. That's what it's there for. Work with the developers to identify why they're running those kinds of queries and how we can tune them to make them more efficient. Now, if there really are no problem queries, then again, maybe the network is at fault. Again, are we running 1 gig Ethernet everywhere for 40 servers and we simply have too much network traffic? In this case, we may have to find the bottlenecks in the network and resolve them. But that's usually the last resort for Async Network IO that I find. So that's my quick walk through the most common wait types that I see in SQL Server, what the causes of them are, and what some of the potential resolutions are. I hope that that's helped demystify some of the language around them because, like I said at the beginning of the presentation, wait statistics are basically a foreign language when you first start, and it can be hard to know where to start. The big thing that I wish you would take away from this is, when looking at wait statistics, one of the first things you want to do is look at what are the top CPU consuming queries on this system, what are the top queries in terms of number of physical reads and logical reads on this system, what are the queries that are run the most frequently, and start with those, because a bad query is always worth tuning. Think about it. If page IO latch is your top wait because you're reading data off of disk and into memory, think not just about how those reads are impacting SQL Server's wait statistics, but think about how all of those physical reads are impacting the SAN and other data that's on the SAN. We want to make that as efficient as possible. If we're running into queries that use a ton of CPU, think about all of the other things on the system that need that CPU. Not just SQL Server queries, but there are Windows processors that need CPUs. There are other background processes that need it as well. That's even more important in a virtualized environment. If you've ever had the good fortune to sit through one of David Klee's sessions on tuning in a virtual environment, he does a great job of explaining how when you have virtualized SQL servers and you send requests to the CPU, SQL Server needs to go ahead and send those down to the hypervisor layer. And at the hypervisor layer, there's co-scheduling mechanisms that try to balance all of the requests that are coming in from all of the virtual machines on the host and which ones are going to run on which servers. So if you have virtualized servers, again, the more well-tuned CPU queries you have, the fewer waits you're going to see overall, not just on the one SQL server, but on all of them. So make sure that finding the worst queries in your system and tuning them is definitely something that's in your wheelhouse. Now, what resources can you use to understand this better and help yourself? There is a white paper called Waits and Queues. It was written for SQL Server 2005, but it's still one of the clearest explanations about what all of this means, and it's still very relevant, even 10 years later. I also had earlier referenced the SQL Server Performance Tuning Using Wait Statistics, a beginner's guide. This is an excellent white paper, an excellent reference written by my friends Aaron Stellato and John Cahias. Highly recommend that you check that out. It's a downloadable PDF. And now I think we have about 5 minutes if we have some questions or thoughts on that. And let me look through the Q&A here. I apologize for some of the audio issues. I am actually in an office today instead of my home office where I typically work, and I think I underestimated the amount of noise that people make versus just me and my dog. So one thing I've noticed, we've got lots of people that are recommending other great resources, and thank you for that. Let's see. There was a recommendation for TempDB. So Raymond says that Vicky Harp, she works at IDERA. She has some great TempDB tools and articles. Absolutely. So thank you for reminding me of that, Raymond. What other questions do we have out there? Yes, Mark makes a great point. Async Network IO can frequently be seen when we're accessing data from Microsoft Access or Microsoft Excel. That is a great point, Mark. Thank you. So you may need to do some work to determine if that's where some of those queries are coming from. Chris says for linked servers, watch for permissions to see the statistics on linked servers and reduce data coming back by restricting rows and columns. Absolutely. With linked servers and performance, prior to SQL Server 2012 Service Pack 1, you needed really high permissions to get good statistics. So you had either the user gets SA or we get good statistics. Thankfully, in newer versions, we don't have that problem. So pay attention to that if you see a lot of OleDB weights. Let's see, Bruce asks, I don't seem to get page latch on TempDB, but instead on user databases. Are there other resources to troubleshoot? Bruce, I would still recommend that you check out the article from Robert Davis on SQLServerCentral.com about TempDB contention. The process that he uses in that to find what's causing the contention should be applicable to any database, not just TempDB. You should be able to narrow that down to sessions or transactions that are having the problems. And a request to go back to the resources slide, absolutely. Again, here are those 2 white papers that I mentioned. Yes, the slides will be given to the DBAFundamentals virtual chapter and be available as a PDF on their resource. Michaela asks, what other SQL Server on VM issues have I seen? That's a big question. Again, Michaela, I would suggest that you look for David Klee's blog and his presentations on performance tuning for SQL Server virtual machines. He can go into that much more in depth and how to properly configure them. A question on, do weight statistics vary on OLTP versus OLAP? Are we going to see different top weights for transactional versus analytical? Yes, definitely. With transactional systems, I typically see more of those write type of weights. With analytical and read-heavy systems, I would typically see more of the read-heavy weights, those page latch type of things. Again, no matter whether it's a transactional or an analytical workload, the process to resolve these common weights is very much the same. And again, yes, the slides will be available. This session was recorded, and I'm going to hand it back over to the organizers just to wrap everything up in the last minute.
Thank you, Jess. That was really good, and as you said earlier in your presentation, weight statistics are a whole new language into themselves, and you really need to look at different things, and this was a great summary of stuff for people to get started with, because that included a lot of the weights that you see. And you had provided great resources, and as always, you broke it down and explained it in a real straightforward way. So I really
Thank
appreciate
you. Yeah.
it. Anyway, really appreciate it. And we had a few audio problems. I think most of it was on my side, but anyway, I appreciate it, and everybody. Let's see, I think we had a couple of questions. People wanted to see a few things. Let me take the presentation back just real quickly.
Sure.
And let's see.
I'm making you the presenter now.
Okay, let's see if I'm showing the right screen. There we go. Let me get rid of the questions. Okay. Let's see. From current slide. And if you want to just kind of do a camera at the top right-hand corner of your thing, that way you've got the dates and the cost and everything. And for session recordings, as we said before, Jes will get us the scripts, and you can get the scripts and/or the recording at Fundamental SQL Pass.org Meeting Archive, or you can go to our YouTube channel and just look at the archive if you're not worried about the scripts. And we'll let's see, we'll be back. Let me go back. I don't even remember. I think June. Okay, we've got the one next week with Down Under, and that's on May the 10th if you're in Australia in that area, or May the 9th if you're in the United States. And we'll see you then. Thank you. Bye.